this out of the way. Is the picture still look good, Shane? All right, I got 1 o'clock. We'll go ahead and get started. And our next meeting will be June 15th. And I'm sure everybody's happy to be back at their office like we all are. So welcome back to the office. And if you didn't pick up on that, that is a little bit of sarcasm. So the class schedule is as it has been for a little bit. We don't have any classes scheduled at all at this point in time. And again, you could go out and check the available online classes that we have. And so you can go out to the link on our page and find all these different classes that you could take through Mo.U. Got a CAD support issue I wanted to talk about. It seems like getting back into the office, we see this a lot. Let me move this out of the way, but you'll see this dialogue trying to launch MicroStation, GeoPack, the SS10 version. You'll get this dialog that pops up, this text window, and what it's saying is it cannot open that macro file, which is on the T drive, or your T drive's not mapped. So one thing you could do is go to your T drive or open up your Windows Explorer and look at your T drive, and if it's got the red X on it, just click it and that will activate it and open it up so that you can use the T drive. Or if it's not there, you would have to just go manually map that drive so that the T drive is available, and then everything will work. It seems like we're getting a lot of calls in the last couple days on this. So just as a refresher, you see this dialog, make sure the T drive's mapped. Got a couple of things to talk about with the ORD update, our Open Roads Designer. We're waiting for the next ORD update, which is version 10.10, which means nothing to much anybody, but it has a lot of fixes in there for it has a lot of fixes out there for us going forward. ORD came out. We've created all the chapters for Road 1. We've done some work with it. It looks good, but there's some processes in there that they needed to fix in regards to cross sections and plan sheets. So they fixed them, and hopefully, well, they're saying it could be out soon at the end of the second quarter, beginning of third quarter, and but they haven't given dates yet. So we're still riding that out to see when that'll come out. We don't want to go before that because it's a total schema change. So we want to do it all at once. And we'll need 3 to 4 weeks to test it after we get it and redo some of the chapters before we contact the districts for any kind of implementation. And when we do so, and it'll be a couple months out yet, you'll either finish the project in SS10 if you're at the cross-section point of it, or you can convert your project. And this will be voluntary. We're not going to just make you move over to ORD or whatnot. It'll be a case-by-case, I guess, decision. Is that kind of correct, Kevin, on that? That's what we want to do on that?
Yeah, I think so. We don't want to force them into, ORD if they don't want to go on their current project. But again, if there's a new project that's starting up, we would like everyone to get on to Open Roads Designer eventually. So the support for SS10 is going to be kind of going away here shortly, and we do need to get on ORD so it's a supported product. So.
Yes, and the update that's coming out has some major fixes to a cross-section plan sheet like I was talking about. It greatly improves the flow of the project, so it's something that we really want to wait for that in the schema change so that we don't have to push it and then go back and do another push later. So we're trying to do it all at the same time. But that's pretty much what we have in the ORD update. There's just really not a date yet, so we're just...
And when that date does come and we test it, we will, get with the districts and we'll, have an agreement with the districts when we're going to come out and start the update, and we'll train everybody, whether it's virtual or in person. We don't know that yet, but we're not going to force anybody in ORD on their current job. It'll just be future jobs that people will have to go to it. So.
Yep. So there we are with the ORD update. Next, we have Julie's going to do some stuff for our highway lighting, and I'm going to stop sharing and make her See if I can find you, Julie, over here. And I'll make you a presenter. And then you should be able to share your screen. It's coming. It's almost like, hey, all right.
Get it to go to. Okay, so hopefully we have, it's still there on the screen for you.
Yes,
So
we see it.
hello, good. Hello, everybody. I'm Julie Stottlemyre, Assistant State Design Engineer, for those of you that I haven't met. Lots of names on here I see going through the list. So today I'm going to try to cover a little bit about lighting design, and I just called it Lighting Design 101. Steve,
Julie, I think you're showing the your second screen.
it doesn't say Lighting Design 101?
Well, we're seeing your next slide too.
Shoot, I see. That's what I was trying to figure out on which monitors.
I
to
kind of like the preview of the next slide, so I know what's coming. So, but
No.
That's perfect. You did it.
that looks good now.
Oh, does it?
Except you got the
Yeah, it's not on presenter mode, right?
yes. I can see your slides off to the left now. The all your slide, your.
Okay, which view do you have now?
You had it for a second. That's
You had it for a second.
No.
Okay, let me go back and stop share, and then I had to move my laptop over from my other screens because of my monitors don't have a camera on them. So I was trying to, so it's still picking up probably from my, and I selected the PowerPoint view. Let's try screen 1 and see what we get. Now, are you still seeing both right now?
We're seeing the same one.
Yep. So let me do a switch. Now, do you have the singles?
There you go.
That looks great.
Yep. Okay.
Yes. Perfect.
Adjustments of coming back to the office, right? Figuring it all out. So, so yeah, Steve asked me to present a little bit on lighting design. I think Steve, as they were doing some conversations with the districts, we're getting a lot of requests about our lighting design software. And just, we were talking about licenses and different things, and just started talking to Steve a little bit about that. And he said, you know, this would be really great for you to share with our CAD advisory group. So today I'm going to go through a little bit of the lighting basics that we have, and our standard plan specifications, all the information that kind of goes into our lighting designs that we have. You also know a little bit about a lot of the layouts that MoDOT has already created for design. But there may be some situations where you might need to get into the lighting design software. And if you need to, that's certainly available to you as designers to be able to do that. But just wanted to share this level basic of knowledge on what's out there, as lighting is a pretty technical subject. I spent many years in the traffic division, of which I oversaw signals and lighting, and was involved with CAD group a little bit on that lighting design software and providing some of the backup information that they needed to be able to complete the software. And they provided a lot of the support, of course, to the design staff for that software. So worked off and on with that. But then in the background, as a user, have went to various lighting design schools, a little bit about the lighting, what goes into lighting design. Lighting is a very technical subject. I know I've heard people in the past say a light bulb's a light bulb, right? Well, light bulbs are very different. And now that we've even went to LED bulbs, they're even more different than what we've dealt with before. So just going to share a little bit about lighting basics. I kind of focus this more on the design criteria, kind of the background into some of our designs, and then I'll go through some of those standard layouts, and then we can talk about the lighting design software from there. And of course, any questions, happy to try to answer some of those. I just, like I said, kept it brief, so we'll see where your questions or any information goes from there. So always wanted to start with, there's a whole lot of information that we have. This is just where all the information is located for lighting as it pertains to design criteria primarily for our lighting layouts. So you can see the engineering policy guide. I tried to highlight each article for that and what you kind of find in each of these articles. 901.9 is the layout section in the engineering policy group, and that really has a lot of the standardized information and links to some of the figures that we currently have already laid out for all the design staff. You'll find a little bit of information in the Missouri Standard Specifications. To note in this is you know, the EPG and the standard specifications and the standard plans usually all have the same number reference. So 901 is lighting. However, we have a 1000 section of the specifications that are usually more directed toward manufacturers of products. So 1091 is really related to the manufacturers of our lighting products. So that's why a lot of the information that I've pointed out here is in 1091 and not 901. 901 really addresses how a contractor would install the lighting, where 1091 is those things we ask for a manufacturer to supply. So we've standardized on our luminaires that we use, and so a lot of the information about those luminaires is in this section 1091. And then standard plans 901, a little bit different in that it does mix up some manufacturing items, but also contractor installation items related to our pole heights, mounting heights, and you'll find in there that pole information, as well as the tilts that we use on our luminaires, the bracket arm links that we use to get our luminaires in the correct locations, and a little bit of luminaire lighting info as well, just as a quick reference to try to help sometimes the contractor on when they're installing those items. But all this really does start with national standards, and I've listed a couple of those just here in the bottom that we often use as our go-to reference when we start, and that's the AASHTO Roadway Lighting Design Guide, and then IES RP08. IES is the Illuminating Engineering Society, and RP stands for Recommended Practice, and the 08 manual is really roadway lighting as it pertains. So the Illuminating Engineering Society does a whole lot of lighting layouts besides roadways, but great technical resources and guidance that they put out too. So the roadway, or the 08, is the recommended practice for roadways. So MoDOT does take all this information, and we try to create standard designs. And we'll talk a little bit about why we do that as we go along through here. But the first thing to start about when we talk about lighting design is we have two types of lighting design that we use on the roadway. One is called silhouette, and one is called direct reflectance. Silhouette lighting really is the best form of lighting, and that's where we put a dark object on a light background. So we're creating shadows. That's really the best visibility that your eye is able to discern and kind of recognize that there's something there. It goes a lot with even our road signs. You know, a lot of our signs, we create high contrast, and we always try to start with the same thing, dark letters on a light background. And if you think about our signs, our regulatory signs are just that. And the reason for that is that because that's the best visibility. Warning signs are black on yellow. road work, you know, is black on orange. So again, trying to create that best contrast and best visibility. So silhouette lighting, you'll see it in the EPG also, is really the preferred lighting method. However, there are times when we need to use what we call direct reflectance, and that's where we're going to shine a light directly onto an object. This is primarily used on when we have an object that's out in the roadway and we want to be able for you to see that that object is there and that it probably has a vertical face to it. So hopefully you're kind of ringing a bell that this is mainly for like where we put islands or curbs or barriers out in the roadway. We want to be able to shine a light directly on the nose of that object so that you can see that as a driver and recognize that there is an object laying there. You can imagine if you tried to place that in shadow, that vertical face would then also create a shadow. And so you'd have black on black and you'd never be able to discern between the object on the roadway. So we'll talk a little bit about those as we look through these layouts. The trick here is that you never want to mix the two. So in our lighting layouts, you'll see them, you'll have silhouette lighting or you'll have direct reflectance, but we never mix the two. And even if we have one, particularly like in intersections, if you have one quadrant that maybe has a curb and you're lighting that curb using direct reflectance, you will go ahead and use direct reflectance lighting on all other quadrants too. And that's just because of creating those darks and shadows and trying to be consistent in the way that the light is coming down onto the pavement. Another criteria we look at in MoDOT is we really just light conflict points. So if you go back and you look at some of those national standards, you will see some layouts that use very many more lights. And we as an agency really just look at those conflict points, so merge and diverge areas, four-way intersections, T intersections, those curbs I mentioned, we want to make sure those are lit up. Just those areas where we're trying to make sure that a driver is able to recognize where another car might be and be able to make any evasive maneuvers or just even to recognize them merging onto a highway with them. We do use very basic lighting layouts. If you look at the national standards, some of them refer to that or partial. And sometimes we're even below that partial lighting a little bit. And some of this came about a change to our design standards in 1973. Now, many of you and many of us may be barely born or not even born yet to remember what happened in 1973. But in 1973, there was a national energy crunch where we were all really asked to conserve energy, do what we could to, help support the grid. And during that time, MoDOT kind of transitioned from, we had some standards that we lit a whole lot of roadway and a lot of ramps, like up ramps and kind of coming down the ramps much more than we do today. And that energy crunch of 1973 kind of pushed us toward more of a very basic lighting and just lighting those conflict points. There are some measurements of light that we look at on a national standard, and MoDOT has chosen to use illuminance as our method of measurement. Illuminance is the amount of light that hits a surface, and it's measured in foot candles. So you will see a lot of these references I referred to on the previous slide with items with a method of being measured as foot candles. Now there's another term called luminance, and luminance is really the amount of light that passes through something. So it's very difficult to do an illuminance design, and the formulas and everything to go into are much harder. So illuminance is a really much easier targeted approach, and it really works great for roadway lighting. So a lot of roadway lighting is designed with illuminance. So that's another thing as you work through lighting designs or just even lighting resources you might read is to make that discernment between luminance or illuminance. So MoDOT looks at illuminance. Mounting heights are another big tool that you'll see in lighting designs. Mounting height, one thing to point out is the distance from the luminaire to the roadway surface. So it is not about pole heights. It's about how high up that luminaire is from the roadway to where that light is coming out. This many times is the input that you would put into your software design criteria. They will ask you a lot of times, what is your mounting height? For MoDOT, we have two mounting heights. We have a 30-foot mounting height and a 45-foot mounting height. And then tilt, as I mentioned a little bit, tilt of a luminaire. Is that luminaire directly shining down onto a roadway, or is it tilted up a little bit? We have two tilts that we use. Again, this often is an input that goes into your design criteria. Our 30-foot mounting heights, we use a 0-degree tilt. And on our 45-foot mounting heights, we have a 15-degree tilt. And we'll look at some more of this as we go along. Voltage is another item you're often asked, especially with LEDs. Voltage can be used to drive LEDs harder, but as we do that, we degrade the life of that LED. So you want to be careful. A lot of times manufacturers can tell you they can meet the light output, but then what they might do is they put a lot of voltage behind that LED to really drive up the output, but then they degrade the life of it. And even a lot of times the drivers that go into the mechanisms of the light, the luminaire itself. So our system voltages we use, this is also for safety of our contractors and our maintenance staff that works on these. We use 120, 240, and 480 volt voltages, system voltages. Now that's a little different than you'll see later on what our LED maximum voltages are. So just a little bit more about MoDOT standard design and just a bit about lighting design in general. All luminaires are classified with an IES distribution and classification system. So again, that IES is the Internal or Illuminating Engineering Society. They've come together and created standardized distribution and classifications. That's so it can be, you know, all luminaires can be standardized across manufacturers into certain types, but also for the lighting design and the calculations that go into the softwares or by hand as they used to do these items. So they've created a standard naming convention. The distribution and classifications really describe the shape of the area illuminated by a luminaire, the spacing, and the light that is given off above a horizontal plane. For MoDOT, our IES distribution and classification system that we use is called a Type 3 MS. And off to the right here of this slide, I've kind of just put the overall graphic that shows you there are 5 types of luminaire distribution patterns. You can kind of see them there in the differences. And if you think about a roadway and where we place our luminaires, many times we're trying to get that light across 2 12-foot lanes of traffic. So that type 1 is a very narrow, might work for like a sidewalk or something, you know, a very narrow path, whereas that type 3 you can see throws out a little farther in front of the luminaire and goes some distance down the road, but maybe not as far as a type 2 might go. And then that type 5 is traditionally, those are like your dusk to dawn kind of lights. So you put one of those up, they have a circular lighting pattern to them. So they will throw light behind them as well as in front and to all the sides. That's one thing about roadway lighting is we don't want the light to go off of our, behind the road. You know, we're trying to put it all onto the road. So those type 2s and type 3s do really good with throwing that light out in front of the fixture. There is a thing called light trespass. If you're big in the urban areas, you probably have groups that contact every once in a while asking about light trespass or roadway lighting interfering with their, you know, homes in the evenings and putting a lot of light into an area. So light trespass and where we throw that light is something we want to be very cognizant about as well. The M is what we call a medium longitudinal classification. So just as it talks about, this is how far that side-to-side direction that the light moves from the fixture. So we not only want light to go in front of the fixture, but we do want it to go down the roadway a little bit. So the M classification for us is that side-to-side throw. For an M classification, its maximum spacing is about 7.5 times your mounting height. Again, if you look at some of our standard layouts, you'll see some of those were very close to that. It's kind of used as a guide. They have an S distribution, which is short. So that side-to-side throw might be like 2.5 times the mounting height. So it doesn't go very far down, side to side down the road. And then they'll have a long distribution, which if I remember, oh gosh, I think it's upwards of like 12 mounting heights is how far it goes down. Well, then that covers a whole lot. But then what we sacrifice with that is then you get more of that light behind the fixture. So again, we're not trying to light ditches, we're trying to keep it on the roadway. So we've picked for our lighting applications a type 3 MS fixture. The S is how much light goes above the 90-degree horizontal. That is shown in this figure kind of here on the lower bottom right, sorry, where we show the different classifications there. So they range from full cutoff to a non-cutoff. MoDOT uses the S, so the semi-cutoff, where only about 5% of our light would go above that horizontal plane. Those that are really concerned about dark skies, are interested in being able to see the stars at night, those kind of groups really like us to use full cutoff fixtures. Again, with the full cutoff fixture, you can kind of see the difference in the diagram. Our effective light then to reach very far out in front of us, you know, it gets hard to always reach that all the way across the roadways we're trying to light, especially when you're talking 2 and 3 lanes wide. But the perceived notion is that a semi cutoff allows a whole lot of light to go up into the air, and it really doesn't. It's only about 5% of that light. So for the difference in cost and what we're trying to do, the semi cutoff really fits our applications pretty well. The non-cutoffs, again, those are kind of those lights that you'll see a lot of times in pedestrian areas where the globes are up on top of a pole. Again, they're throwing kind of like that type 5 light pattern, and then they're throwing it up just as much as they're throwing the light down. Whenever we move to LEDs, though, these distribution patterns were really tough. So that's why it took a little bit for the LEDs to come around in roadway lighting, especially at those heights that we are trying to mount those on at those 30 and 45-foot mounting heights. And LEDs are a little trickier about how do you manage the throw of the lights. With the bulbs that we used before, you know, we had refractors, so dropped glass lenses that went into the luminaire that refracted the light, so we could bend that light that came out of that source really pretty easy and kind of, you know, mold that light to look where we wanted it to go and how we want it to throw. But LEDs, being a point source, are much harder. So when we put them in, you know, they're very much harder to control and where that light goes. So that medium classification in the semi cutoff was a little harder and a little challenging with LEDs. So the industry has come up with a new rating, and you'll see this in our standards as well, called the bug rating, or it's about backlight, uplight, and glare. And it's this one diagram, these two diagrams kind of show that. So again, that backlight, kind of like I mentioned from before with the distribution types, we're trying to keep that light onto the roadway, not put it onto somebody's home or light the ditches. You know, we want it to go where we want it to go. The uplight is kind of that comparison of how much light goes above that fixture. Again, just trying to keep that useful light pointing down, also to be cognizant about those dark skies and allowing people to be able to view the sky and the stars at night if they'd like to. And then of course, LEDs are can be very bright, and they're much more glaring to the eye than the lights we previously used, those high pressure sodiums. So glare was another issue we started seeing in LEDs. And so we also have a glare rating that they have come up with for LEDs. You can kind of see the spectrum of where those fall. So what they do is they do testing on all their point sources, kind of with using the circle of light, and they measure where these lights fall. So the B rating, you know, they have these 3 areas of light they will measure. They try to keep not as much light in the BL or the BH and put all of it into the BM kind of area. And then they come up with these ratings. So a B2, a U0, and a G2 is pretty good ratings, and that's what we use for our LED fixtures. We have 2 bug light ratings that you'll see. The 30-foot mounting heights use that first B2, U0, G2, and our 45-foot and some other applications will use the B3, U0, G3. So was a lot of, as we migrated from high pressure sodiums to LED, it was great working with all our consultant partners in the industries to just understand and come up with this. So I just threw that out there as a little bit of information about this, because I think it's important to understand that a little bit as you work with lighting design too, what those ratings mean. So again, MoDOT has some standard design criteria. You know, you can put into these softwares and get all kinds of information out. And there are many more outputs that you will get from the design criteria. And we just used a few of them here that we look at when we looked at our lighting design. So average maintained intensity is one of the items that we require our lighting designs to meet. Average maintained intensity really accounts for degradation of a bulb and dirt buildup on that bulb as well. So as it sits out there over time with the emissions and everything that take place, as well as just pushing that electrical voltage behind a bulb, the bulb will degrade, and then the dirt will degrade how much output comes from a light. So we look at average maintained intensity over the life of the bulb. And you can see here some of those average maintained intensity amounts we're looking for. So when you do your lighting design criteria, this would be an output. And you're looking for, depending on what kind of lighting you're working with, continuous lighting, like as mentioned on here for freeways, we want to be about 0.6 foot candles, so a little bit brighter than some of the other average maintained intensities you see on continuous lighting of other roadways. But again, those, you know, it's just based on the classification of the road. But then basic lighting at intersections and interchanges, we back up those up to 0.6 foot candles. So pretty much look for 0.6 foot candles as an output after we put all this information into your software. Minimum intensity is another one we look at MoDOT, 0.2 foot candles. Again, there's a maximum intensity. We don't really use that, and we'll go over that in a minute of maybe why, but we do average maintained intensity and minimum intensities. The uniformity ratio. This is a really important, another output of the design to look at. It really has to do more with continuous lighting. You do not have a uniformity ratio when you're just looking at intersections or just, you know, one light placed somewhere. But if you have more than one light that you are putting in along a roadway, uniformity is a really important item to look at. MoDOT has chose to look at the average maintained intensity to the minimum intensity. There's average to max, there's max to min. Like I said, we just use this one uniformity ratio. And what this does is it ensures consistency in your lighting. So you're basically not throwing somebody into areas of light and dark. Just imagine what happens when you've been in a bright room and you enter maybe a dark closet or something. As you get older, particularly, it takes you a little longer to adjust to those transitions. Or tunnels are another great place where uniformity is very important, where you go from bright to dark and then dark out to bright again. So you're just trying to make sure that eye has time to adjust. You know, it's not good if somebody, when they're driving at 60 or 70 miles an hour, has to kind of all of a sudden shut their eyes because they can't see or can't see where they're going into. So uniformity is very important. This is an output for For our mounting heights of 45 foot, we look to a uniformity ratio of 4:1 or better. And for our 30-foot mounting heights, we look for a uniformity ratio of 6:1 or better. 1:1 is the perfect uniformity, because I know it was always hard for me to say, well, what's better than 4:1? So a 3:1, a 2:1, or a 1:1 is better. But to get those perfect uniformities, a lot of times you compromise on spacing. And so that's a balance that you'll have in coming up with these. But that 4:1 and 6:1 are the two uniformity ratios we use. Again, offsets or setbacks, you'll kind of see them called both, is another input item that you'll have, and we have standardized these as well. Just a note is that this is not the location of your pole. Again, the lighting design is always about the location of the luminaire, not where your pole is at. So our setbacks we have for 30-foot mounting heights, we want that luminaire located plus or minus 3 feet from the edge line. And we have different bracket arms that are links that are available to help you get the pole where you need to get it, but also get the luminaire in a spot where we want it, that, like I said, that plus or minus 3 feet from the edge line. So you can use these different bracket arms for those 30-foot mounting heights to get that luminaire. And then for the 45 foots, we try to do plus or minus 5 feet basically from the edge line. And the bracket arm links aren't as many for those. And when you get to look at those layouts, you'll see those. So 6 or 15 foot are the bracket arms like that. We do have a little caveat in there about if you have clear zones, if you've calculated your clear zone and it's greater than 20 feet, then we say go ahead and do a 15-foot setback. And then when you use the 15-foot bracket arm, you can get pretty close to where you need to be on those. But clear zone is considered. That's something else we get asked a lot. Clear zone is considered, and so sometimes there are some caveats for that. As we went to LEDs, the initial lumens, how much they put out, their light, and the wattages they use, as I mentioned, were some concerns with industry, and just again trying to balance that longevity of light, but yet creating standardization. So MoDOT has these 3 initial lumens for our LEDs. Again, this would be an input factor that you would put into the lighting design criteria. So you would need to know your location and which luminary you're using, and then your initial lumens are an input that you would put into that. I just wanted to also note that we do have a maximum wattage on our LEDs. This isn't necessarily a input that you put into the criteria for your lighting design, but it is important to note that the maximum wattages for the LEDs aren't necessarily matching those system voltages we talked about earlier. So this is how hard we allow that manufacturer to drive that LED with the wattage that they can apply to that. Some of that is adjustable, really crazy games that they can play with LEDs. So we limit how much they can drive those LEDs so that we don't degrade our life too fast. As I mentioned in that previous, one of those previous slides talking about average maintained intensity, I talked about it's average maintained intensity is an output that you get, but it's degraded by the life of the bulb and the dirt that happens on the bulb. So in our specification in 901.7, some of that I talked about for manufacturers, you'll see that we actually tell those manufacturers what those maintenance factors are. So your average maintained intensity is usually your initial lumens, and then you degrade it by your maintenance factor. And so just want to point those out, that if you're doing that, that's where you find these for those design criteria that you would do as an input. So our light loss factor basically is less than 1. LEDs are pretty good. They don't build up too much. They don't degrade too much over life. You know, a lot of times they fail immediately when you turn them on, and otherwise they will just hang on for many, many years. This light loss factor was a lot lower with our high pressure sodium bulbs, but LEDs were able to up that a little bit. So again, just kind of making you aware of these, that then the light loss factor really is a combination of what they call lamp lumen depreciation. a luminaire dirt depreciation, and a luminaire ambient temperature factor. So LEDs are really more susceptible to temperatures than high pressure sodiums were. So the temperature factor, if it's really hot, LEDs don't do really well. So this is a new factor that's been added into that maintenance factor. So just letting you know these are there. And if you're doing the calculations and they ask you for these items, this is where you go find those, 1091. Again, it's important you use these same numbers so that you're comparing your lighting designs all the same. Just of note, one thing you'll see too is an item called a color rendering index. This is how well you're able to discern colors. So light bulbs are not all created equal. High pressure sodiums had a better color rendering index than, if anybody remembers, low pressure sodium. So you really could use a low pressure sodium bulb and go into a room with a lot of light, turn on that low pressure sodium or a lot of colors on the wall, wherever, furniture, anything, turn on a low pressure sodium bulb and everything would look black and white. So high pressure sodiums were a little better at being able to recognize colors. We have a couple places where we think it's really important that you're able to discern colors, and that's like on our signs. So our signs will use a different light bulb that's able to have a better color rendering index, so you can tell those greens from the reds from the blues that are up on top of the signs that we use to light those up. So for our LEDs, we said we want a color rendering index that's no less than 50. And I just tried to kind of put on here what the color rendering index goes all the way from a 0 to 100, where 100 is the best and 0 is poor. This is something you can also look at. Just I was telling somebody the other day, when we're in the home improvement stores and my husband might be looking at items, a lot of times I'm looking at light bulbs or LEDs, and I'm looking at some of these items on there, just trying to learn more and figure out how they're all rated. Also in your home, it's a good thing if you're wanting to figure out, you want to be able to see colors better, do those kind of make more true, you might want to look for an LED bulb that has a good color rendering index. 100's the best. The other item that's important with LEDs is called nominal color correlated color temperature, so CCT. You can see on the scale here at the bottom for the colors of light, some light bulbs you can, maybe people didn't really notice these with some of our incandescent bulbs we had, but they really put off kind of a yellow or orange kind of tint to the room. Where LEDs, if you've probably noticed, some cars have really bright and really white LEDs. You may buy some LEDs and they're really, really white and they seem really bright. Well, that's just because of this temperature scale that they might be on. So the higher the degrees Kelvin of an LED, the more toward that really blue light that light's going to look. Whereas the cooler temperature ranges, the more yellow or orange it's going to be. We have chosen for our LED installations, this is one thing we noticed in our pilots when we started them, and we started getting what we called the hot whites up toward that 7,000 Kelvin degree. They seemed to be really bright and really glaring, but what it was is just they were really in that white and blue spectrum. So once we kind of brought those LEDs down into this 3,000, 4,000 kind of Kelvin degree temperature, they really looked more like what was out there today. And so that was really important that we try to keep the look the same of what we had with our high pressure sodium. So we specify our LEDs to have that 3,000 degree Kelvin CCT, just to help keep them from getting really white and blue. So let's talk a little bit. So MoDOT in the background has went through all this information that I just presented to you, and we've created standardized layouts. So went through, and you can see, I didn't even count how many are on here, like 10 different probably layouts that have been created to help with any designs that you might have where you would want to install some luminaires. So that's why I say to really need to use a lighting design software shouldn't be needed very often, because we've created all these standard layouts for you. And if we have some time, we can go look at these. But I just mentioned them here that like if you're working on an interchange and you want to know where do you need to place your luminaires, you'll go to that figure and you can see that we show you if you're using a 30-foot mounting height, here's where the locations go for your pole, typically in the gore and right at the merge point. If you're using a 45-foot lighting layout, you can get by with one pole and where that would be located. So you have your different interchanges. We've also done intersections. We've done roundabouts. We've showed you if you have those islands, channelized, islands, divisional islands, any of those that you're trying to light. We have lighting plans that show you for those as well. You'll see one in here for the discernment lighting. For silhouette and one for direct reflectance. We also show those IES type of illumination, some of those figures I showed you a while ago. So if something's not quite right or you need to move a pole because you have something in your way that's supposed to go right there, a sign maybe, or it might be something a little harder to move that might be in your way. Maybe you got a culvert or a drainage structure right there where you need to put the light. It'll give you those ranges where that maximum light occurs, like I talked about, those 7.5 mounting heights side to side, and the throw out into the roadway, so that you can adjust those poles a little bit and know and still meet these average maintained intensity uniformity ratios and minimum intensities that I talked about earlier. So there's really a lot of configurations already out there for you. So why did we do all this? So we, in the background, did all this and created those standards for you. Just to, one, it helps with the efficiency of the design staff. That lighting design can take a little bit of time to go through and do. And so by creating these standard layouts, we've made it really easy for design staff to kind of just pick up those figures and plot them onto your design plans, adjust them a little bit for any locations, and you're already meeting all those criteria that we've selected and want our designs to meet. It also helps create some standardization. So it makes it easy for, think about the maintenance of the items, the, inventory of items as we have to repair or replace those items. By creating standard pole heights and bracket arms, all of that makes ease for maintenance, for replacement, and also for inventory. So we don't have all kinds of different lengths of poles that we have to keep, or all different lengths of bracket arms to keep, or even different kinds of luminaires to keep, because each design is different. So it does help with that. It also makes it easier for contractor installation in that they know every time when they install this is the light bulb or the type of pole they're going to have to install, and the foundations, as well as those luminaires to keep on hand for their jobs that they might be installing the luminaires on. It also, the lighting designs, we take into account the utility costs. So LEDs has really brought this a lot down, but you might be surprised at how much MoDOT pays every year just for utility costs between signalized intersections and lighting. So it's quite a bit. So any of that money we can save, we're always interested in doing that as well. And then safety of contractor and maintenance and motorist, I talked about that a little bit. It might be easy as a designer to up some system voltages so that you can run, some different lighting and things like that. But we don't want our staff necessarily working on, I use this example. We actually do have a bridge that has some very high power voltage systems to that. And that's really dangerous, and who wants to put our staff at that risk of working on those high voltages. So that's something else we take into consideration. And then if those are hit, and thinking about a driver that might become entangled with some of those voltages and those wires around there. So we want to try to keep that as minimal risk as we can as well. So that's all those things that kind of went into the process behind the designs that we created. So then what do you do? if maybe you do have some layout that doesn't match our standards. There might be some we run into. You might have a bridge close by, and if you put up that 30-foot or 45-foot pole, your light is up on the roadway up above instead of lighting your roadway that goes under the bridge. So you may have to adjust some mounting heights or do something a little different. We're getting creative with some of our intersection and interchange designs, and so we probably won't have a layout for that. So maybe you need to use the software to look at those different intersection designs you're going to look at. So if you don't have that standard layout, then by all means, you certainly want to start utilizing the lighting software that we have available to help you with your designs. I put on here, Aladdin used to be the one that we had and was supported for many years, that was provided to us from one of our manufacturers, who was gracious enough for just allowing us to use that product. They have since discontinued, and I put on here Dialect. Shannon can correct me. I think that's the one you're talking about, migrating over to now, is the Dialux program. So every manufacturer kind of has their own lighting program. There's some that are nationally used, and I think Dialux is probably one of those is that represented by any one manufacturer, Shannon, or all the manufacturers kind of using that one?
I think there's quite a few of them out there. Yeah. We import a lot of it in, so I think pretty much anyone that's out there, there's several.
Right.
Yeah, there's a bunch of them.
So why is it important to try to have one that's more open? Is because, like, this next step I talk about is that you would have to even start on a new lighting design, you have to have that IES photometric curve. Some call them photometric polar diagrams, some call them ISO foot candle diagrams. I showed one here off to the right. So what this is a graphical representation. If you take this one that says ISO foot candle curves and you mirror that, that basically is showing where all those light points of that luminary hitting the pavement. You can look at the details here. It'll tell you at a certain mounting height, this is the intensity you'll kind of get at this area. If you were to flip that over, you'd kind of see that mirrors that type 3 distribution that we talked about earlier. But you have to have these IES photometric diagrams. So what you have to watch out for, and what we've tried to do when we pick a software company, is that whatever software we're using is open to any company's ISO foot candle curves, even though they're standard. Some companies lock it down to where only Cooper, their design software will only use their Cooper curve. So we try to make sure that we're using one that will let us bring in GE or Cooper or American Electric Lighting. Oh gosh, there's so many different, Leotech, so many different lighting manufacturers that we work with. And you'll find the approved lighting luminaire manufacturers on the MoDOT approved products list that is created by Traffic Division. So you also want to make sure that you're trying to go to those companies that we've worked with and use those ISO foot candle curves that are for those luminaires that we've specified. So those type 3 MSs, and start with those curves. Those curves, when we approve a manufacturer to be on our approved products list, we require them to give us their ISO foot candle curve. So then what that allows you to do, and Shannon, hopefully that has been kept up or you have those, then what we do is we kind of
Yeah, we have those.
Good. We give those over to CADD, and then that's one of those first things that you have to import into the design software is this ISO foot candle curve. So that's what you have to start from. So you don't want to be reaching out to manufacturers necessarily directly unless we just end up with a luminaire type that's not on our approved list that you have to use. So you want to start with those. Again, then as you start working through the design criteria, as I mentioned, those inputs and outputs, you're going to want to try to keep all those standard design criteria that we have used. And that's important because especially if you're going in next to other intersections or other interchanges, you want those average maintained intensities to look the same as you go down the road. You want that uniformity ratio to kind of to be the same as somebody would move down the road. So you also have to look beyond just your one area you might be working on, but also what's around you and making sure that we're keeping all that similar for that driver experience and the way that the eye works. So that's why it's important that you do that. Most of the time when you go through the software, the thing that you're going to be really looking and adjusting is going to be spacing and probably heights. Those are going to be the two variables that you're not going to probably have any inputs for, and you're going to let it, you go play with those spacing and those heights, and still trying to meet those minimum maintained intensities and that minimum intensity. And if you're doing continuous lighting, those uniformity ratios. We do suggest if you're doing lighting designs for other than a roadway, if you're doing trails or a pedestrian path, those are some requests we've gotten before. Any of those kinds of things that we really do just reach out to our consultants. We do have lighting consultants on the on-call list, and they have been picked as consultants that do lighting designs and are very fluent in the softwares and all the technology that goes behind the different luminaires and getting those lighting designs done. So that was kind of that quick lighting 101, a whole lot more to it, but just tried to share what goes into lighting design, what MoDOT has done, how we've come up with our standardized layouts and why they're there. So if you have any questions, I'm happy to answer those, or if you want to look at some of those figures, we can look through some of those and talk about how you would use those figures as well. So I'll stop sharing and.
Yeah, Julie, there's a question in chat.
Okay.
If you can see the chat.
Okay. So it says, if upgrading an intersection that was designed as silhouette, but now will require direct reflectance in order to light the islands and curves, should the silhouette be removed and designed as direct reflectance? I've heard it was okay to have both because the old concern was due to voltage difference and not just to mix the circuits. No, we would recommend that you would make them all the same. So if you're going from silhouette to direct, that you would create direct reflectance for if it's 4 quadrants or however many quadrants you're working with. And like I mentioned, that's just because of that shadowing kind of effect when you have the difference of where you're placing those lights and how they kind of interact together. There is a difference with system voltages. That is another thing to consider. You don't want, if one was running on 240 and one running on 120, we usually try to keep, especially those 240 and 480 voltages, we try to keep in separate conduits from our 120s. Again, just a safety precaution for our maintenance and contract staff working on those. But it's really just more about how that light comes down and is reflected and picked up by the eye for all those objects in the area.
Thank you, Julie. Anybody have any other questions? Let me share my screen or change my stuff.
Did it help? Was it good? Didn't know really where to start, so just kind of picked up something and went on.
They're usually pretty quiet. We'll get emails afterwards. But
okay.
but any other questions? Anything else?
Hey, Shannon, will you be the one to contact for Dialux?
Yeah, it would seem so. And I can share my screen real quick, Bill, if you'll let me.
Yes, I will.
Show you where these support files are located, so you can pull those down.
1 second. There you are.
I've actually had a training class in it, so I'm.
What do you on as Michael Smith? Yeah. Okay.
Yeah.
You never know.
Yeah. All right. So I'll share. I guess you can see that over there, the CAD Services website. Okay. So on our CAD page, we have this support files area. And if you scroll down to the bottom, we've got other applications. And we've got the Dialux lighting software. We've got their website, We've got our manual that you can go out there and look at. It's actually their manual, not written by us. And then the zip file contains the IES files that Julie was talking about. I think it's from 150 to 400 watt IES files that can be imported into the program and used inside of there. So we do have that. If you need more information on it too, I might have some videos to share with you, possibly, that might help you get along with that. So, yep, I guess I'm the man.
So if they want Dialux installed, they would still contact you and you would be able to install it for them?
Yeah, I can get it installed.
Okay.
Yep. Okay, Bill, it's back to you.
Thanks, man. Okay, any other questions before we go? Thank you so much, Julie. Appreciate that.
Welcome.
I
Thanks for
think
inviting me.
next, oh, anytime. Next time I think we're having Kevin. He's going to put on a presentation. So stay tuned for that next month one. Woohoo.
It's not Jim?
No, he sent me a
Oh.
screenshot of something that
Oh,
he's
okay.
doing it. So
Well, we'll miss Jim.
yeah.
Julie, one last question. Do you have to be really bright to use the software?
No, boy.
Really? You don't like that? What? What was this? Okay.
Oh, man. Okay, well, that concludes the meeting for this month, and we'll see you next month.
It sounds
Have a
good.
good
Thanks,
one.
Joey.
Have a good one.
You can edit that out if you want.
I edit a lot of it.
Hey, whenever Julie retires,
Yes.
we'll have to hire to train down at CAD after that. So.
Okay. Did I pass?
You passed. See you
I
guys.
ended up talking a little bit longer than I thought, but
That's all right.
Well, that's what we kind of thought, Julie. This
Yeah.
is Chris Schwantner, by the way.
yeah. Okay.
All right, I'm ending it. See you guys.
All right. Bye.
See you, Bill.